So, good evening, all of you. All set for the last session. I hope you have correctly understood everything after Subodh sir's address on Thursday about the institute, about the study patterns over here, about the prospects for hardworking children. We essentially look forward to hardworking children. Natural talent and understanding is one thing, and readiness to work hard sometimes overtakes some children who may have a natural talent but they are lazy at work. Some hardworking students, they many a times they perform much better and they take better heights. So if you are ready to work hard, if you have loved what we did in the last 12 sessions, if you found it something different than what or how you do it at schools, it is very important that you feel the difference, that yes, this was something different and this was so interesting, and this has really taken my attention. I have enjoyed. I want to learn many more such things, many more such techniques, many more such ways to prove the results that we use. If all this has taken your attention and you feel ready to work hard, then MPI is the right place for you. For all your hard work, for all your sincere inputs, all our faculty members will put in 200% of what you give it. If you express some doubt or if you express some to learn something more, as Subodh sir said, we take our students right up to international levels where we chip out international level medalists so many times, and even if not medalists, they represent our country or they reach the national level. That is the top 20 or 30 students in whole India. Before that, top 20 or 30 students in Mumbai, Goa, Maharashtra region, Maharashtra, Goa region. So that is a result of hard work and work in the right direction. So all that atmosphere and all that infrastructure you will get over here with your hard work and perseverance, readiness to work for 4 years, 5 years, and even more. That becomes a great combination, because one of this cannot bring the result. Child is hardworking, but he doesn't have the correct guideline, he cannot bring out result. There is a correct guideline, but the child is not working on that, we cannot bring out results. So both things put together, we can uh, bring out great results, and these are qualitative results. Like, it's not just about scoring marks or getting ranks or getting medals. What you will learn in this whole program will be your lifetime companion. That understanding, then it is like learning to learn. It is called as learning to learn. So it is not about just one theorem is taught to you. You are taught how to think, and then in the same fashion, you can think everywhere and anywhere else. So, with excellence in one topic or these three topics, you will have the keys of how to learn better, how to know things better, how to learn by ourselves. What is the track by which we should go? How we should scrape from square one right up to the top. So it is like handing over the fishing rod. We will not fish for you. We will give you the fish rod. That take this fish rod and fish for yourself now. That type of self-learning techniques are developed at our institute, and that is a very unique feature. We will not bind you to the teachers. We will try to free you from the compulsion of taking something from a teacher. So it is an experience worth to be taken for students who are ready to put in a lot of effort in the direction we give. And at a point, you never feel it like an effort. Like, if you're liking some sport, those who love cricket can be on the cricket ground for 12 hours also. They will have no issues. They'll not feel tired. the game you love, or if you love drawing, painting, then you can sit for your painting, sit painting for 4 hours, 5 hours. You won't even know how you spent 4 hours, 5 hours. Like that, when you start liking a subject, you never feel that you are putting a lot of hours or you're taking a lot of effort. That becomes your pleasure. You love to work, so you can go on working for hours and hours without feeling that burden or compulsion. And then learning becomes just like some sport or a favorite activity. It is no more a burden that some school work is given and I have to do that, then I have to write some exam, then I have to get some marks, then I have to go to the next standard. All that goes off. And you just become pure learners that no, I like to learn this, that's why I'm doing this. I don't know what is going to happen next, but I'm loving to do this and I'm going to do this. I'll do these experiments, I'll do this research work, I'll keep working and thinking on one problem. I'll think about it in several ways. So the whole process becomes a lot of fun. And that is our motto, that to make your journey also very, very interesting is what we look at. All right, it's 7 o'clock. Let us begin with our last lecture discussion. Now, as on Thursday, I was again and again dropping out. I know that the last our practice problems we could not discuss in detail. So, just in case we finish today's problems on an earlier note, we will discuss those problems also. Otherwise, they were pretty simple problems, and some of those problem types will come in our today's discussion also. So, and you will of course get the solution after our today's lecture. But just in case we get time, we will discuss that. Now, let us go for the first problem. What is the measure of the greatest angle in the adjoining figure? Now, the angles given are x plus 15, 4x plus 35, and x plus 10. Now we know that sum of all angles in a triangle is always 180. So when I add these three, the total should become 180. What is this? 4x plus x is 5x plus x is 6x. I can add all x's together. And then I will add all numbers. 15 plus 35 is 50 plus 10 is 60. So 6x plus 60 becomes 180. Now when I will get this 60 on this side, plus will become minus. So 6x will become 180 minus 60, that is 120. And 6x is nothing but 6 into x. So x will be 120 divided by 60. Okay. So x is 20. And if x is 20, what will these angles be? This is 20 plus 15. So this will be 35. This is 4x plus 35. So what is 4x? 4 into 20, that is 80. 80 plus 35. Okay. So that will be 125. And x plus 10 will be 20 plus 10, that is 30. And they are asking the greatest angle. So it will become 125. Now, up to finding x, it was fine. But after finding x, is it really essential to find all the three measures? Because we can see by our eye that these two angles are acute angles, so they are lesser than 90. And this is an obtuse angle, so this is greater than 90. So obviously, this is going to be the greatest angle. And they are asking us only the greatest angle. Have a measure of this angle, or have they asked us a measure of all three angles? No. They have just asked the greatest angle. So wherever it is a time bound question, like suppose you have 1 minute per question or 2 minutes per question, then you should develop the skill of skipping what is not essential to do. So finding this value 30 and 35 was not essential in this question. What is essential? Greatest angle, that I can see like that also, that this is the greatest angle. So I will just find the value of 4x plus 35 once I know the value of x, and my answer will be 125. So this one skill you should develop in yourself, particularly when it is a race with time. You will be doing so many competitive exams wherein you will need to actually decide how much time you have per question, and then time your work and see to it that you're not taking too much extra time. That is the time management during the exam. If it is a 1 hour paper and if there are whatever 25 questions or 30 questions say, then you have only 2 minutes per question. Then you should not be taking 5 minutes or 10 minutes per question. When there are 2 minutes, sometimes you may take 3 minutes, some questions you may finish in 1.5 minutes, so you will compensate. But you should have a fair optimization of how much time per question, and in such question it becomes very very important to learn to skip what is not needed to be done. You should be doing only what is needed. Okay, now second question. Following are the ratios of the three angles of a triangle. Ratios. Which of the ratios is that of a right angled triangle? These are the ratios. So what will I need to do? I will need to consider the actual measures as the ratio multiplied by the constant of proportion. So if the ratio of the angles is 2 is to 3 is to 5, then the actual measures may be 2x plus 3x plus 5x. Okay. And I know that the total of 2x plus 3x plus 5x is 180. So what is 2x plus 3x plus 5x? 10x. So 10x is 180. So x is 18. X is 80. Now, if x is 18, then what will be 2x? 2x will be 36. What will be 3x? 3x will be 18 3s are 54. And what will be 5x? 5x will be 90. So the measures of the angles are 90, 36 and 54. So is this a right angle triangle? Yes, because one angle is 90. What are they asking? The following ratios, which of the ratios are that of a right angle triangle? So yes, 2 is to 3 is to 5 is a right angle triangle. But does my story end over here? Maybe there are more than one ratios which are of right angle triangles. So I will have to check for all of them. So what will be the story for 3, 4, 5? 3x plus 4x plus 5x will be 180. So 5 plus 4, 9 plus 3, 12x. 12x is 180. So x will be 180 upon 12. That will be 12 ones are and 12 fives are 60. X is 15. If x is 15, 3x will be 45. 4x will be 60 and 5x will be 75. I also need to check that the total is coming 180. Huh? Here it was coming, what was x coming? 18. Huh? So here it was 36, 54 and 90. Is that adding up to 180? 6 plus 4, 10, 0 carry over 1, 5 plus 3, 8, plus 10, 18. Yes. Then here the measures are 45, 60, 75. There is no 90-degree angle. Therefore, this is not a right angle triangle. Then here it will be x plus 3x plus 5x. 5 plus 3, 8 plus 1, 9. 9x is 180. So x will be 20. If x is 20, 1x is 20, 3x is 60, and 5x is 100. So now see, this 45, 60, 75 is an acute angled triangle. All three angles are acute angles. But now see here, this is 100, 60, 20. So this is an obtuse angled triangle. One angle is obtuse, 100. But this is not a right angle. Then look at this, x plus 2x plus 3x, that is 6x is equal to 180. So x will be 30. If x is 30, 1x is 30, 2x is 60 and 3x is 90. Look, one more triangle measure 90. So this is also a right angled triangle. 30, 60, 90. Okay. So what will be our answer? Options 1 and 4 indicate right angled triangles will be our answer. And now I'm going to give you one research project. I want you to draw one 30, 60, 90 triangle, meaning this is a 90 degree. I want you to draw this angle to be 60. Let this angle be 60 degree and this angle be 30 degree. So this will become a 30, 60, 90 triangle. This is typically called as a 30, 60, 90 triangle. Then I want you to draw one more 30, 60, 90 triangle on this side. This side is common. Then make one more 30, 60, 90 triangle such that this angle is 60. So what have I done? First, I have drawn, say, triangle ADC, which is 30, 60, 90. And with AD as the common arm, I have drawn another 30, 60, 90 triangle ADB. Now, these two 30, 60, 90 triangles are attached back to back with their base angle 60. And then I want you to find out what type of triangle is this. Now, after joining two 30, 60, 90 triangles, and can I find the area of this triangle using some different formula? Can I find some different formula for the area of this triangle? This will be a big research problem for you. We know that the area of a triangle is half base into height. We also know that ADC is a right angle triangle. So I can apply Pythagoras theorem to the right angle triangle. And after joining two triangles of 30, 60, 90, what type of triangle is this formed? And if I tell you that the length of the side of this triangle is S, then can you find a different formula for the area of such triangle formed? This will be your research problem. And if you can find this answer, absolutely claim a good chocolate from your parents. Set a bet with your parents that if I find out this problem, if I all by yourself, not by asking anyone or not by looking into the Google, by your own thought, if you are able to find out this, you can ask for a good big gift from your parents. That means you're going to discover one more formula for the area of triangle. We have learned one formula, half base into corresponding height. Now we can find one more formula for the triangle. Let us go to the next problem. The area of the triangle is 162 square centimeters. The area of triangle PQR, it should, of triangle PQR is 162 centimeters. If the base and height are equal, so suppose this is my triangle PQR. All right. This is my triangle PQR. And the base and height are equal. So suppose I take QR as some base with whatever length, let me call it P centimeters, P. Then the height, corresponding height is also of the same length. This is the height I will draw from P to QR. So this is the height corresponding to QR. We have learned that it is always perpendicular to the base. And what are they saying? That the base and its corresponding height are same in length. What is that length? They have not told us, but they are same. And the area of the triangle is 162 square centimeters. So can I find the length of the base? If my base is P and my height is also P, then my area will be half into base is P into height is also P. Half base into height is my formula, no? Half base into corresponding height. Both are PP. So half into P is 162 is what they are saying. Now, what is P multiplied by P? What is a number multiplied by itself? Is it the square of the number? 2 multiplied by 2 is 2 square. 9 multiplied by 9 is 9 square. So P multiplied by P is nothing but P square. So half of P square is 162. Okay. Now, I want to find the value of P square. When I take this 162 or half on this side, this is denominator, so it becomes numerator when it crosses the magic river. So P square is 324. P square is 324. And if P square is 324, what will be the value of P? P will be under root of 324, no? Square root of 324. If P square is 324, then P will be square root of 324. Now, how do I find the square root of 324? If you know it by heart, what square this is, great. Otherwise, I can find it by approximation between 10 square 100 and 20 square 400. It is ending with 4. So as we learned, the square root will end with 2 or it will end with 8. So this can be the square of 12 or 18. Now, I can see that 324 is very close to 400 compared to 100. It is far away from 100. So I judge this will be 18 square. If you don't have time to um, actually find 18 square and confirm, you can directly do this. So 324 is 18 square. So the base and height both are 18 centimeters. Another way of finding square root of 324 is factorization. 324 is 2 into 162. It is 2 into 2 into 81. So it is 2 into 2 into 9 into 9. Do I have two pairs? One pair of 2 and one pair of 9. So what is this the square of? I will take one from this pair and one from this pair. 2 into 9, 18. So 324 is 18 square. Now let us confirm if the area is coming right. If the base and height both are 18, then half into 18 into 18 is 2 ones are 2 nines are 18 nines are, which comes equal to 162. Okay, that is how you can approach this sum. We also revised our methods square roots. Now see, we are as such doing geometry, but in doing geometry, we needed a tool that we have learned in squares and square roots. So in the end, it is nothing like this topic and that topic. It is the overall understanding, and you need every understanding. You can need any understanding anywhere. So we have used our square and square root technique in finding out. In finding out our measure of angle. Okay, so it is like overall understanding. You need anything anywhere and everything everywhere. You cannot say, and then as you go ahead, you will need your understanding in maths to solve your problems in physics. You will need your understanding in maths to solve your problems in chemistry. Okay, so it is not about one subject. Finally, it is the blend of all the subjects put together that gives you a concrete understanding. Next question. In a right angled triangle, one of the acute angles is 5 times the other. A right angled triangle is given to me. And one of the, we know that in right angle triangle, one angle is 90. So that is out of question. And the remaining two are always acute angles because their sum is 90. If one angle is 90, then for a right angle triangle, the remaining two angles are always acute. I will never be able to draw an obtuse right angle triangle. I can never draw an obtuse right angle triangle because if one angle is 90, the remaining two angles together are 90. So one of that angle can never be greater than 90. All right. Now, what are they saying? One of the acute angles is 5 times the other one. So if one acute angle is say x degrees, I don't know what it is, then the other is 5x degrees. Then this will be 5 times of this. And what do I know about them? I know that their sum is 90 because this is 90. So I know 90 plus x plus 5x is 180. Sum of three angles, no? So x plus 5x, 6x will be 180 minus 90. That is 90. So 6x is 90. X will be 90 divided by 6, that is 50. So the smaller angle is 15 and obviously the greater will be 75. You can do this without x also. That 9, these two together is 90 and this is 5 times of this. So obviously this plus this will be, it will be like our train method also, 1 compartment, 5 compartments. So total 6 compartments. So I'll have to do 90 divided by 6 to find the smaller angle. Okay. So we are using our train method in doing questions based on right angle triangles. We are using our understanding of squares and square roots to do our questions based on right angle triangles. Okay. So my answer is smallest angle will be 15 degree. Then the next question. The base of a right angled triangle is 8 centimeters and the hypotenuse is 10 centimeters. The base of a right angled triangle. We know that there is a base and there is a height of the right angle. What are they saying? Base of the right angle triangle is 8 centimeters. And the hypotenuse is 10 centimeters. Find its area. Now, what have I learnt about a right angle triangle? Suppose the right angle triangle is PQR. What I know about a right angle triangle? That this arm, if I am taking QR as the base, then my PQ, which is the other arm of the right angle triangle, is my height. And my area of right angle triangle is half base into height. Now I know the base, I know the hypotenuse. Can I find the length of this arm? Yes, I have a tool called as Pythagoras theorem, by which I know that the square of the two sides making the right angle, or the square of the base plus the square of the side, is equal to the square of the hypotenuse. I don't know what is PQ, so I will keep PQ square as it is. I know what is QR, so QR square will be 64, and I know what is PR, so PR square will be 100. So I know PQ square is 100 minus 64, which is 36. And if PQ square is 36, PQ is 6 centimeters. And then I know the base also now, and I know the height also. Base is 8 and height is 6. So 2 4s are 8, 6 4s are 24 square centimeter. Please remember that we will always write the area in square units. Never write it as only centimeter. Never write it as only 24. Nobody will give you marks. Of course, in your, when you are asked to enter only the number, in your NPI exam, they will just ask you to enter the number. There you don't have to enter the units. But in any subjective exam, area should never be written without units. Perimeter, area, surface area, volume, always with units format. Okay. So the area of this triangle will be 24 square centimeters. This was the classical method of application of Pythagoras to find the area. So we are cross using. We are using our understanding of Pythagoras to find the height, which is also one of the arms of the right angle triangle, and then to use it in the formula of area to find our answer. Now, is there a need to do this whole thing to find this? By now, have we already done a few questions and we know the Pythagorean triplet 6, 8, 10. So if the hypotenuse is 10 and one arm is 8, the other arm is going to be 6. This is a very, very typical Pythagorean triplet 6, 8, 10. The other day we saw a Pythagorean triplet 30, 40, 50, which I pointed out to you that this is 3, 4, 5 multiplied by 10. Each number multiplied by 10. What is 3, 4, 5? It is our smallest Pythagorean triplet with natural numbers, all natural numbers in it. So 3, 4, 5 into 10, I got 30, 40, 50. Can I relate 6, 8, 10 to 3, 4, 5? Is there some number which if I multiply 3, 4, 5, I will get 6, 8, 10? 3 2s are 6, 4 2s are 8, 5 2s are 10. So 3 into 4 into 5 multiplied by 2, I am getting a Pythagorean triplet. Oh. Let me try with 3, 4, 5 multiplied by 3, all. 3 3s are 9, 4 3s are 12, 5 3s are 15. 9 square is 81 plus 12 square is 144 is 4 plus 1, 5, 14 plus 8, 2, 25, 15 square. Wow. Try with 3, 4, 5 into 4. Try with 3, 4, 5 into 9. Try with 3, 4, 5 into 7, into 12, into 13, into 145. And see if you can come to some generalization to find the Pythagorean triplet quickly. So out of the 3 numbers, if 2 numbers are given to you and they are some multiples of 3 and 4 and 5, can I find now the third multiple without doing regular Pythagoras theorem, square of this minus square of this, or square of this plus square of this, and quickly land on a Pythagorean triplet? Please think over this. These are all handy tricks to reduce your calculation time. And this is something you will need to find by yourself. Starting from an odd number, I have shown you food for thought. 5 square 25 is 12 plus 13. And 5, 12, 13 is a Pythagorean triplet. 5 is an odd number. 6 square 36 is divide by 2 is 18 is 8 plus 10. 6, 8, 10 is a Pythagorean triplet. It is an even number. See, if you get some generalized formula for a Pythagorean triplet to be found out with an odd number, with an even number, make your own observations, put it down in your own diaries. Next question. The length of the base of an isosceles triangle. What have we learnt about an isosceles triangle? It is a triangle which has 2 sides equal. Okay. So let me call this triangle LMN. And I know that isosceles triangle has 2 sides equal. Now what are they telling me? The length of the base of an isosceles triangle is less by 3 centimeters than twice the length of congruent side. Clearly understand the information given. Suppose my congruent sides of the isosceles triangle are x centimeters. They have to be same, no? then the length of the base is less by 3 centimeters than twice the length of congruent side. So congruent side is x, twice of it will be 2x, and less by 3 than twice will be 2x minus 3. Converting the word problem into mathematical expression. 3 less than 2 times the congruent side. And the perimeter is 17. Now what will be the perimeter of this triangle? It will be the side, sum of the sides of sum of the lengths of all three sides. So x plus 2x minus 3. And they are telling it is equal to 17. So what is x plus x? 2x plus 2x is 4x. 4x minus 3 is 17. 4x is 20. So x is 5. Now this is 5. So obviously this will also be 5. And then what will this be? If x is 5, 2x is 10. And 3 short of it will be 7. So the sides are 5, 5, 7. Is the perimeter 17? Yes. Tally. Or if these two sides are 5 and perimeter is 17, obviously third side has to be 7. No need to do this 2x minus 3. You can do it that way also. If x is 5, this side is 5, this side is 5, and they're telling us perimeter is 17. So the third side has to be 7. And then it is 2x minus 3. You can do the tally that way. Or you can do the tally this way. Okay. So questions are not difficult. You should develop a method of understanding what is asked very clearly. And then you go step by step. You will get most of the questions. If you feel confused and if you do something half-heartedly, another very important thing is that should always first read the complete problem. Read the complete problem and then only start solving. Never start solving it as soon as you've started reading it. First read it completely, understand, then make your equation or expression and then solve it. Okay. Now, an isosceles triangle has one side 5 and another side 7. The third side is not given. What are the possible perimeters of the triangle? It is an isosceles triangle. So what I know, two sides are equal and the third side is different. Now, one side is 5 and another side is 7. So what are the possibilities? That the two congruent sides are 5 and 5 and the third side is 7. Then what will be the perimeter? It is just like our triangle in the previous question, no? 5, 5, 7. So then the perimeter will be 70. What is the other possibility? That the congruent sides are 7, because they have not given whether 5 is one of the congruent sides or 7 is one of the congruent sides. So it could be 7, 7, 5. And is it fitting in our rule of three sides of a triangle? Is 5 plus 5 greater than 7? Yes. Is 5 plus 7 greater than 5? Yes. So these can be the dimensions of a triangle. That also we have to see, no, that this plus this should always be greater than this. Otherwise, it will never make a triangle. So it could be 7, 7, 5. If it is 7, 7, 5, then it will be 7 plus 7, 14 plus 5, 19. Perimeter will be 17 or 19 centimeters. Now the unit for perimeter is never a square unit. It is the unit of length. These lengths are in centimeters, perimeter is in centimeters. If these lengths are in millimeters, perimeter is in millimeters. Don't put square on it because perimeter is addition of lengths So the unit remains the same. Area is multiplication of length. So we will multiply the unit by unit also, and therefore it becomes a square unit. Okay. So the possible perimeters are 17 and 19. Now there is a very smart way of thinking over this. Do I really need to do the, yeah, if they had asked the difference in the perimeters of triangles, yeah, I will need to do this when they are asking me the actual perimeters, that I need that the perimeters are 17 and 19. But if they had just asked me the difference in the perimeters of the triangle, then I should be able to judge that it is all, it will be 2, no? Because if two sides are 5, if two sides are 7, what will come the difference in their sums? It will come 2. So that is a judgment question, but that will come if they have asked the difference. As long as they are asking the actual perimeters, it is essential for us to do the question as we did it just. Then next question. As shown in the adjoining figure, triangle ADC is a right angle triangle. Given measure angle ADC as 90. Don't raise your hand. It is our last lecture, and if you're not learning it by now, that there's no point in raising the hand. ADC is a right angle triangle. This is 90. AC is 5 centimeters. DC is 4 centimeters. DB is 1 centimeter. Find the area of triangle ABC. Now see, they are asking me the area of triangle ABC. What will be the area of triangle ABC? It will be half into the base. What is the base of ABC? BC. Into the height. Now, what have we seen for ABC is an obtuse angled triangle, and I'm finding the height of the base which is making the obtuse angle. So I will need to draw a perpendicular from A to BC, but I will never be able to draw it on BC actually, because it can never become 90 degree. So I will need to extend BC and then draw a perpendicular on it. As we saw in our last lecture, that for obtuse angled triangle, the height of the base that makes the obtuse angle triangle lies outside the triangle. So this is my triangle and this is its height. And that height AD, whatever, is giving me nothing but the right angle triangle ABC. See, this is 5, DB is 1, and DC is 4. And what is ADC? Is it a right angled triangle? Yes. And what is AD? AD is the height of ABC triangle. So what is my area of triangle ABC? Half into BC into AD. And now can I find AD? Yes. AD is the arm of right angle triangle with hypotenuse 5 and one side 4. So what will be AD? By now we know 3, 4, 5 is a Pythagorean triplet. So AD is 3, found out, which is the height of triangle ABC. And what about BC? Can I find what is BC? DC is 4 and DB is 1. And what is BC? DB plus BC is DC. This plus this is this. So this is 4, this is 1. So BC is 3. So what is my area of triangle? Half into 3 into 3. half into 3 into 3, that is 9 by 2 square centimeter. Are you following this? So I had to use two things. First, I had to know that AD is my height, and by using Pythagoras, I can find the height. And then to find the base, I had to do 4 minus 1 because DC is given 4 and DB is given 1. So this is 3. So my area will be half into 3 into 3, 9 by 2 square centimeters, or it may be 4.5 square centimeters. Or those who have decimal understanding, it will be 4.5 square centimeters. Now there is another way of finding the area of this triangle. What is triangle ABC? Is it triangle ADB, ADC minus triangle ADB? ADC minus ADB will give me ABC. Follow this. And I know what is AD, what is DB. So what will be area triangle ADB, ADC will be half into AD, that is 3, into DC. What is DC given? 4. And what is area triangle ADB? It is half into 3, height is same, and what is DB? 1. Now, and what is area triangle ABC? ADC minus ADB, that will be half into 3 is common for both, and this minus this will be half into 3 into 4 minus 1, that is 3. Answer is going to come same any which way. Half into 3 into 3, 9 by 2. So if I know the conjoint areas, I will know that area of this triangle plus area of this triangle is the area of this triangle. You will need such type of understanding to solve many problems. Our next problem is in fact a similar problem, to find the area of the shaded region, where we will need to take the same understanding ahead. A, as shown in the adjoining figure, ABC is an equilateral triangle. What is the meaning of equilateral triangle? Measures of all sides is same, with side 6 centimeters. So equilateral triangle with side 6 centimeters, meaning this side is 6, then this side is also 6, and this side is also 6. That is the meaning of equilateral triangle. All sides are same. Length DE is 4 centimeters. Length DE is 4 centimeters. And height AH of the triangles is AH, the height of triangle ADE and triangle ABE both. It is a perpendicular drop from A to DE also, and it is a perpendicular drop from A to BC also. So AH happens to be the height of triangle ADE also. It happens to be the height of triangle ABC also. Find the area of the shaded portion. So how will I attack this problem? if I find the area of triangle ABC, and if I subtract the area of triangle ADE from it, will I get the area of this blue part? Because ABC is full triangle, and if I remove this ADE part of it, I will get the area of the shaded region. So area of shaded region will be area of triangle ABC minus area of triangle ADE. Now, what is the area of triangle ABC? It will be half into what is the base? 6 BC. Half BC into AH. Height is AH. Minus, what is the area of triangle ADE? It is half into the base is DE into height is AH. So is half AH common in both? Can I take it common? Half into AH into bracket BC minus DE. So what is AH? It is 3√3. And what is BC? 6 minus DE is 4. That will be half into 3√3 into 2. Now this 2 will get cancelled with this 2, and the area of the shaded region will come 3√3 square centimeter. Now the height is also 3√3 and the area is also 3√3. So is the height and area same or different? Research problem. How can the height be same like area? Gadbad hai kya? Mistake hai kya? Is there some mistake? How can the height be same as area? Think over this. Find it out. Whether we have done some mistake. Another way of doing the same question, I can find the area of this triangle separately, and add it. That will be the area of the shaded region. No. Now, if this full is 6 and this is 4, I can assume this to be 1 and 1. No. It is not given that these two triangles are congruent. Of course, they should have given it. But suppose it was given. If it is not given, I cannot assume. But if it is given that BD and EC are same, if one additional clause is given that BD is congruent to EC, this is the sign of congruent to, that means equivalence. Then what will be the area of triangle AEC? It will be half into EC is 1 into height is same. Now again, this is an obtuse angle triangle with height 3√3 outside the triangle. So it will be half of 3√3. And even this will be half of 3√3. Half into 1 into 3√3. So it will be half of 3√3 plus half of 3√3. That will be 3√3. That way also we can find the area of the shaded region. All right. So that finishes our discussion problems for today. I think it is time now. Yeah, there are 4 more minutes to go. So I don't think we'll be able to do the questions of lecture 11 in 4 minutes. We have already discussed it last time. and I will be sending the uh, solutions to you, detailed solutions, because we will not be able to do it in 4 minutes. Okay, so the whole thing was a wonderful experience for me. I have enjoyed, though I'm really sorry I could not talk to you all. I would love to see you going into the corridors of MPI, Siddharth Towers, or our other centers for the foundation program, and later on for 11th, 12th at Siddharth Towers. And maybe you will find me walking in the corridors of Siddharth Towers. I am not a maths faculty at MPI. I don't teach maths at MPI because all our other maths teachers were very, very busy. I was handed over this program because I was a little free. But I teach chemistry at MPI. So suppose you all join MPI, then maybe some of you all may have me as your chemistry faculty. Otherwise, all the very best to you. Wherever you go, keep in mind that sincere hard work will take you where you need to go. Wherever you go, work very sincerely, follow your heart. If you're not liking some subject, be very open to your parents to tell them that I'm not liking this subject. You will be liking something or the other. Every child comes with an intelligence. Every child is intelligent. So never ever feel that if you don't like some subject or if you don't score well in school, then you're not intelligent. It is just that your area of intelligence is not amongst the school subjects. Maybe you're not intelligent in history, maybe you're not intelligent in science, maybe you're not intelligent in English, but maybe you're really intelligent in cooking. Who knows? Maybe you're really intelligent in some sport, in some music form. So every child is intelligent. So never ever feel that I'm not intelligent, I'm not competent. If you're not liking something, try to find what you're liking and talk to your parents. I'm sure all your parents will support you in what you like, in pursuing what you like. And when we get to do what we like, we can work like mad. I like to teach. So last 35 years, I'm teaching very fondly. I don't feel tired when I'm teaching because I love to teach. I love to interact with children. So when you get what you like, you will throw yourself into that task. Let it be anything. Let it be anything. Try to find what I'm really liking and what I can do for next 50 years without getting tired. That is where you need to be. All right. So all the very best to you and hope to see you in MPI for sure. We will love to have sincere and sweet children like you with us, and all our teachers will bring out the diamonds from you. They will sculpt the dry diamonds, and all of you all will shine with us or wherever you. Okay. Bye and all the very best.
Thank you, ma'am.
Bye,
Bye.
ma'am.
Bye.
Thank you, ma'am.
Thank you, ma'am.
Thank you so much,
Thank you,
ma'am.
ma'am. Thank you.
Bye, ma'am.
Thank you,
Bye.
ma'am.
Bye.
Bye, ma'am.
Bye. Bye. Bye.